Let's continue with the normal distribution. I want to briefly talk about two formulas. We've already talked about the norm dist formula, where the norm dist finds a probability. Specifically, it finds a cumulative probability, or the area under the curve to the left of some value on the horizontal axis. But what if we want to find that specific value on the horizontal axis? If we want to find that, then the input is the cumulative probability and the mean and the standard deviation. And here's a nice easy way, a picture that shows that. If we have a normal distribution, and if we want to find the area under the curve, which is the blue, you're going to use the norm dist formula. But in norm dist, and you can see the first argument is the value on the horizontal axis. And then the norm dist returns the area to the left of that, which is the probability that you're going to get a number at x or less than or equal to x. You always got to put in the mean and the standard deviation. But what if you want to find this? What if you want to find this? You're going to use this formula, norm.inv. If you want to find the value on the horizontal axis, you put in norm.inv, and look what you have to put in. If you're going to solve for x, you've got to put in the area under the curve, or this probability. That's what goes here. And then again, the mean and standard deviation, and it gives you that number. Let's do an example in Excel of doing that. Here's a problem where we have daily demand at a gas station. We have demand at gas, and the average is 100 gallons. And the standard deviation is 100. So we have daily demand is 1,000 gallons on average with a standard deviation of 100, and it's normally distributed. So what is the probability that we're going to, that demand is going to exceed 1,100? What is the chances that we're going to need more than 1,100? So if I had a tank, and I'm trying to figure out how much gas to have in there at the beginning of every day. Let's say I have a tank, an underground tank that can hold 1,100 gallons. What are the chances that I'm going to run out? And so, first of all, to solve for that, we want to find the probability that our demand is going to be less than or equal to 1,100. This should say 1,100. This is wrong. This should say 1,100. In fact, we'll fix it right now. This should say 1,100. The probability that demand is going to be less than or equal to 1,100, we're going to find an area. We're going to use the norm dist with 1,100, 1,000, 101. And then the chances that we would run out, that demand would be greater than 1,100, is 1 minus what we just solved for. So that's a good example. Well, let's go over into Excel and solve that problem. And I'm just going to go over to the right a little bit. And I'm going to, here's my mean, it's 1,000. And here's my standard deviation, is 100. And this is x, 1,100. So if I want to find the probability that my random variable is going to be less than or equal to x, I use the norm dist and put in my 1,100, put in my mean, put in my standard deviation. And when we use the norm dist, the argument, we always use 1 as our last argument, which is true. And that's going to give us the probability that our demand is going to be 1,100 or less. 84% of the time, we're not going to exceed 1,100. But that's not what the question is asking for. The question is asking, what are the chances that we'll have more than that? If I had 1,100 gallon tank, what are the chances that if that was full at the beginning of the day, that at the end of the day, before the end of the day, I run out? Well, that would be the probability that x is greater. Oops, sorry. X is greater than 1,100. Well, how you solve for that is you take 1 minus the probability that x is less than or equal to 1,100. So we're just going to say equal to 1 minus this. So the chances that we're going to run out is about 16%. Back to this problem. This is asking us what should our tank size be so that we're going to have a service level of 99%. I want to have a tank large enough that 99 out of 100 days I don't run out. How would I solve for that? Well, I'm solving for a specific value on the horizontal axis such that the area to the left of that is 99%. I want to solve for the x, and if I'm going to solve for that given an area under the curve of 0.99, this is how I would solve for it. So let's go use that. And so what is my tank size? X, and you're going to use norm.inv. And I want my service level, which is a probability of 99 or higher, or 99, the mean of 1,100. And that means that if I have a tank of 1,232 gallon capability, the chances that I would exceed that is 1%. The chances that demand would be less than or equal to that is 99%. So what if I says, well, I want to make it 99.9. Well, then the 1,300 gallon tank. Now you can't ever put in 100% because this never gets to, you don't ever, the normal curve line never touches 0. But you could kind of make this stupid big. It says, well, what if it's 99.999%? So I put that in there like that. So probably if you got a 1,500 gallon tank, you're guaranteed that you would never run out. Okay, that's a good applications of the normal distribution. We're going to talk about a couple more things normally related in the next 2 videos. Thanks.